In this video, I'm going to show you how to find the local maximums and minimums of a function using a technique called the first derivative test. If you have a function that looks something like this, you can just visually see where the local maximums and minimums are. Maximums and minimums exist where the tangent line to the curve is either horizontal or can't be drawn. In this example, the derivatives of the function are 0. Note that for the maximum point, the slope is positive to its left and negative to its right. For the minimum point, it's the opposite. The derivative changes from negative back to positive. Knowing how the derivative changes at a maximum or a minimum allows us to test for maxes and mins, even when we're not looking at a graph. Let's take the function y equals x cubed minus x squared minus x plus 4. The first step of using the first derivative test is to find the critical values of the function. These are just the x values where the derivative is either 0 or non-existent, like where we had horizontal tangent lines in the previous example. The derivative of our function is 3x squared minus 2x minus 1, and we're going to set that equal to 0 and then factor to find our critical values to be 1 and negative 1/3. Now we can use a number line to test whether the derivative is positive or negative on either side of each critical value. I'm going to plug in negative 1, 0, and 2. You could pick any values on either side and in between. We find that the derivative changes from positive to negative at x equals negative 1/3, and from negative back to positive at x equals 1. So we have a maximum at negative 1/3, 119/27, and a minimum at 1, 3. If you'd like to learn more about the first derivative test, go check out the reading and practice test from ck12.org.